These are the three kinematic equations. They're used to calculate the motion of an object, but I know a lot of people who misuse them or don't really understand them, so I'm making this video to explain how to use them and when to use them. So kinematics is the study of motion or the math of motion, and these equations describe how they move. What you first need to understand is that these equations are only going to be used when you have a constant acceleration, which is the change in velocity. So, like you're dropping a ball or a car speeding up with a constant force. So, the first equation is final velocity, or the speed or velocity that you reach, is equal to the starting velocity plus acceleration times time. So this equation tells us about how the velocity changes. The velocity is equal to vi, the starting velocity, plus at, which is, you can think about it as the change in velocity. Seeing as acceleration, a, is the rate of change of velocity times t, how long it's accelerating for. That basically is the definition for change in velocity. So this equation is best used when you don't really care about how far or the distance, you only care about the velocity. So the next equation, delta x, or change in x, is equal to initial velocity times time plus 1/2 at squared. So this equation tells us about the change in position or displacement of an object. So the VIT term is the initial velocity, the starting velocity, so how fast you're going at the beginning, times time. So basically, how fast you're going times how long you're traveling, that tells you how far you went. So that's basically what the equation is. The second part of the equation, plus 1/2 at squared, that basically gives you the distance you gained from how fast you're accelerating. So let's say you're moving in a car, if there was no acceleration in the car, then the equation a would be 0 and the equation will cancel out to final velocity or change in position is equal to the initial velocity times how long you're going. That makes sense if you're going at a constant velocity. But when you're accelerating, you need the added 1/2 at squared term to account for the increased distance from when you're accelerating. So you really want to use this equation when you only care about the displacement, but you don't care about the final velocity. The final equation is what I like to call the squared equation. It's final velocity squared is equal to initial velocity squared plus 2a times final position minus initial position. So this equation is really important because it's the only equation that doesn't really care about how long it's been happening or the time factor. So, for example, when you drop a rock off a cliff and you want to know how fast it is moving after it traveled a certain amount of distance, not a certain time. So this is a pretty important equation to memorize. So the derivations of all of these equations come directly from calculus, but each equation is useful in its own specific kinematic question. You want to use equation 1 when you want velocity, equation 2 when you want position, and equation 3 when you don't need or care about time. If you want to see a video about me deriving these equations from calculus, please let me know in the comments. Or like a video explaining and doing practice problems with these. Don't forget to like and subscribe, and I hope you stay tuned for the next video.